So let me read my next problem, that is problem number 4 in the lecture, and this one is telling that a hydrometer, that's the device for measuring density of a liquid, with a cylindrical stem of diameter 3.50 millimeter, weighs 1.90 into 10 to the power minus 2 Newton. How much deeper will it float in alcohol than in an oil, is given that relative densities of the alcohol and oil are 0.820 and 0.900 respectively. It's common knowledge that since oil is heavier than the alcohol, so this hydrometer floats with more portion sticking out of the liquid in oil than in alcohol. Alcohol being less dense, this hydrometer floats the greater part of its volume immersed under the free surface. So I shall draw a figure to understand the problem situation. This is a container filled with oil, and suppose the hydrometer, this is a device as I already told you, has got a cylindrical stem of given diameter, and it floats with only a part of the stem sticking out above the free surface of the oil. Now another situation, that is the position of this hydrometer in an alcohol. I just put two figures side by side, so I draw a horizontal line for proper comparison, and this container contains some alcohol of less density. So the same hydrometer now floats with a greater part of its volume immersed under free surface. So you can see by comparison, in this case the stem has gone deeper, and if we could draw two horizontal lines through the tips of the hydrometer in these two figures, this difference in height, let me call this as h, we have to find this value of this h. So I read the question once again. For the hydrometer, the cylindrical stem that is sticking out of this liquid surface, that one's cross section is circular of diameter d is equal to 3.50 millimeter, means into 10 to the power minus 3 meter in SI unit. The weight of the hydrometer, that is capital W, is equal to 1.90 into 10 to the power minus 2 Newton. This is also the force of gravity acting on hydrometer, because you know that in inertial frame the weight and force of gravity have the same magnitude. Further given, for the alcohol, relative density is 0.820, which means the density of alcohol by density of water, this ratio is 0.820, but since density of water is known to be 1000 kg per meter cube, we conclude that the actual density of alcohol is 820 kg per meter cube. Similarly, since relative density of the oil is 0.900, it follows that the actual density of the oil, that is equal to 900 kg per meter cube. This is the information given, and as I said, you have to find out how much deeper does the stem go when it is transferred from the oil into the lighter alcohol. That is the question here. So let us examine first the floating condition of the hydrometer in the oil. And we know that there are two forces acting on this hydrometer. One is the force of gravity acting downwards, and the other is the force of buoyancy acting upwards. And these two forces must have equal magnitude, because this hydrometer is in floating equilibrium. So we write down condition for floating equilibrium is Fg is equal to Fb. Now in inertial frame, the force of gravity and the weight are the same thing. Therefore, I can write down Fg is equal to 1.90 into 10 to the power minus 2 Newton. That equal to the force of buoyancy. By Archimedes principle, it is the weight of the displaced oil. Now, if I could highlight the portion of hydrometer immersed under oil surface by this shading, this immersed volume, let me take it to be capital V. Now this V is also the volume of the displaced oil. So the displaced oil's mass is given by capital V into density of the oil, and multiply this by free fall acceleration g, and you get the weight of displaced oil. That is also the force of buoyancy exerted by the oil onto this hydrometer upwards. I don't know the value of V, it's my assumption, the immersed volume of this hydrometer, but putting the other two data, we can write down, this is giving me capital V into density of oil, that is 900 kg per meter cube. The value of free fall acceleration 9.80 meter per second square. Complete the calculation and show that capital V I am getting in 4 significant figures, 2.154 into 10 to the power minus 6 meter cube. I write in one significant figure more than the data given to avoid any rounding of error. So that is the volume as shaded here of the hydrometer that remains immersed in the oil in floating equilibrium. Now, armed with this result, let us now focus on the flotation of the hydrometer in this alcohol. So once again I can write down for equilibrium the force of gravity acting on hydrometer Fg must be equal to the force of buoyancy exerted by the alcohol onto the hydrometer. So, but this time if you compare these two figures, you can see since alcohol's density is less than oil, the hydrometer has dipped further into the liquid, and this amount of dipping, that is taken to be H, say. Remember, this is the stem part only going down further. So if we compare these two figures, this is the extra portion, that is a portion of stem of cross-sectional area of diameter d. If I could take this cross-section of this stem, that is A, this A is equal to pi upon 4 into d square, isn't it? D being diameter of this cross-section. So that is the area of cross-section of stem. And if a further depth of H goes down, now the extra volume of hydrometer, which is now immersed under the liquid, is A into H.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.